Dear listeners of WHCR 90.3 FM, the voice of Harlem, welcome to tonight's program. This is Angelo Lampousis, your host from City College of New York. Aaron Sloduvning is doing a great job in the sound, and I'm doing an awful job in pronouncing his name, but I will keep trying. And we have with us, as every Monday, our fantastic group of honor students here in the green room of WHCR. Our guest today, live here in the studio, is Professor Spiro Alexandratos, professor in chemistry from Hunter College. Professor Alexandratos, Spiro, welcome to City College.
Thank you very much. Pleasure to be here.
We have in this class and through this program highlighted some of the environmental issues that affect our daily lives. And in fact, we recently reviewed a particular book. It's called A Civil Action by Jonathan Harr, an investigative journalist. And the book is a real story about a contamination case from Woburn, Massachusetts. Later, also a very successful movie by the same title. John Travolta is in the movie and Robert Duvall. In this particular story that, like I said, it's a true story, there's a strong case, a real case about water contamination affecting an entire community. In this case, the suspect was the old industrial activities in that particular location. They had to do with tanneries and so on. So you are an expert in the field of water contamination and water pollution in general. Would you, if you could highlight for us some of the issues related to this very essential topic and very essential resource?
It is both an essential resource and an essential topic. The sad part about the book and the movie, A Civil Action, is that it is a scenario that is played over and over again, not just across the United States, but across the world. It's a very real issue of contamination, and it happens in communities large, such as our own here in New York, and communities small, just as the one that you alluded to in Massachusetts. I have my own honors students at Hunter College read an article on New Bedford, Massachusetts, a very small community along the coast in Massachusetts, and it also was contaminated with metals and is now, part of it is a Superfund site. They had the EPA administrator come to Massachusetts and talk about how much money would be devoted to cleaning the harbor there. And the problem is always metals. Metals are particularly toxic, and once they're in the water, they're very difficult to get out.
By coincidence, in today's class, there was the notion by the author, and we discussed it in class, about some of the industrial chemical compounds and elements that they have been used in the processes of leather manufacturing. Things like blue vitriol and Goldberg salt and sulfuric acid, of course, that is used in so many applications. Would any of these materials, first of all, this is a silly question perhaps, but are still in existence or in use today, or we're talking about just legacy type of issues?
To a large extent, it is legacy. I don't think very much has changed in terms of the tannery chemistry that's being used, but what has changed is a realization that you can't simply dump wastewater into bodies of water that people live nearby. So there is more pollution control that goes on. We've come a long way technologically. Some of that technology is expensive, but companies are willing to do this. Well, the Environmental Protection Agency insists upon it, thank goodness. And so there is a lot of work that is done to prevent pollution at the source. We understand so much of it now, but to a very large extent, the problems are legacy at this point, yes.
And if we want to be a little bit more specific, we will try to keep this at a level that we can all understand, because we're not all experts in chemistry, but you are a very gifted educator, so perhaps you can give us a sense of how do we trace these things, and how do we decide how bad they can be for one particular environment, if we're talking about investigations?
One takes an analysis of the water, and so one would go, for example, to New York Harbor, to New Bedford Harbor, to any body of water and take a sample. We do that here. We take samples of water and we take samples of fish. And so, for example, in New York Harbor, quite a few years ago, samples were taken of the fish, especially those that are ground dwellers, those towards the bottom, things like crabs, and also sea bass, which are not at the bottom, but those are important fish commercially, and their flesh is analyzed. And oftentimes you will find within them organic compounds. And those organic compounds can be dyes. In the case of New York, which is a huge problem, it's the PCBs. PCBs were used as capacitors. PCBs as a molecule look perfectly benign. You can't look at it and say, oh, of course, it's going to be toxic, but it builds up in the body, first in the fish, and then as people eat the fish, then within people, and it is a neurotoxin, and it attacks the nervous system. We understand that now, and in New York alone, we're dredging the river, the Hudson River, up near Troy, New York, and the barges are there. There's a lot of dredging. The EPA is overseeing it, and we're trying to purify the water in that way.
New York has a reputation for having some of the best drinking water in the nation, and perhaps in the planet, for such a large urban environment. But the water comes from upstate, right? We don't drink our groundwater.
No, we don't drink our groundwater, and that is a very, very interesting study, because it's a lesson to the United States. It's a lesson to the world as to how we get our water. We get our water from upstate New York. We get our water from the Catskill Basin, and it is a body of water surrounded by mountains. The rainwater flows into the body of water, and what New York City has done is buy a lot of the land around the lakes to prevent any commercialization of that land. As a result, it remains pure. It then comes through conduits, through Van Cortlandt Park, to our tap, and it very proactive. The mayor has been very proactive on this and really deserves a lot of credit in keeping our water at the very high level it is.
Now, I hate to ask this, but does this fact that we get the water from upstate and not for directly beneath us, the groundwater, like they do on Long Island, for example, that they drink well water, does this have any correlation with how do we treat our backyards?
It's very, very sad how we treat our backyards, yes. We're probably, I suspect, the only species that decides it's okay to use toilet water for drinking water. We will take our garbage, we'll throw it into the rivers, and then we'll say, okay, 10 miles down, it's all pure again, let's go ahead and drink it then. Except it's always 10 miles down from someplace else, and the pollution is a real issue. Fortunately, it used to be an issue far more than it is now. Through New York, we have our wastewater treatment plant. We have one right here, of course, on 125th Street. Absolutely excellent. It protects the quality of the Hudson River water, which we don't drink, but it's perfectly safe to then to go kayaking, as they do around Battery Park City. So one has to be proactive. We have not done a good job of taking care of our bodies of water, but again, proactive politicians are doing their job, I think, very well, certainly in this region.
This has been very helpful so far. For the listeners who just tuned in, you're listening to WHCR 90.3 FM, the voice of Harlem. This is Angelo Lampousis, your host from City College of New York. And we talked to Professor Spiro Alexandratos, professor in chemistry from Hunter College. We anticipate Professor Alexandratos' questions eventually from our honor students who are sitting across us in the green room. In the meantime, I would like to squeeze in another topic, if I may. And I know from your perspective and your scientific angle, if you could, you have things to share, for lack of a better word, about global warming. And it is an issue that perhaps have been over-discussed, but at the same time, I find, and I speak for myself, that there's certain aspects that we just, in all of this volume of the discussion, there are certain aspects that they are still not widely evaluated and discussed. So would you please give us your perspective on this issue?
It's funny you should mention that, because I just came from my own Macaulay Honors class where I spent an hour and a half being grilled by students on just this very point. So if students have any questions on this here, I'm more than happy to deal with it. The problem is that we as a species throw on the order of 30 billion tons of carbon dioxide into the atmosphere every year. The question then becomes, is that affecting our environment? There are people who say that it affects it insofar as global warming is concerned, insofar as the glaciers melting is concerned. I can clearly tell you, knowing chemistry at all, I can tell you, game over. There's no discussion. There's absolutely no discussion. You look at the carbon dioxide molecule. Carbon dioxide as a molecule necessarily absorbs infrared radiation. Where does the infrared radiation come from? It comes from Earth. The Earth is absorbing the ultraviolet light from the sun. The plants become warm. When you feel the plant becoming warm, when you feel sand becoming warm, it's warm because infrared radiation is being emitted, though you can't see it. That enters the atmosphere, that hits the carbon dioxide molecules, it causes them to vibrate just a little bit faster. They have a little more energy at that point. They then hit an oxygen molecule in the atmosphere, which hits a nitrogen molecule in the atmosphere, and then, like a domino effect, one hitting the other, eventually one hits the top of a glacier, which causes a water molecule in the glacier to move just a little bit faster. Multiply that trillions and trillions of times, and there's your phenomenon of global warming, which is grounded within the molecular structure of carbon dioxide.
I don't think, and I'm not overstating any here, I don't think I have heard a more concise answer on this very complicated issue, so thank you for that.
Not at all.
We will have a quick break for our station ID, and we will be coming back shortly with questions from the students and the audience. Stay tuned.
Bacteria and man are mostly carbon, hydrogen, nitrogen, and oxygen. Come on and meet the elements. You and I are complicated, but we're made of elements. Like a box of paints that are mixed to make every shade. They either combine to make a chemical compound or stand alone as they are. Team up with other elements, making compounds when they combine, or make up a simple element formed out of atoms of the one kind. Come on and meet the elements. Check out the ones they call the elements. Like a box of paints that are mixed to make.
Touch that dial. Keep it locked on WHCR 90.3 FM, the voice of Harlem.
About chemistry, won't you show me everything you've learned? I'll memorize it.
Dear listeners of
I'll
WHCR,
memorize it.
this is a very good sound effect. We have prepared this all week long, so now we are back. This is Angelo Lampus, your host, and the program Innovation Unedited from City College of New York. We speak to Professor Spiro Alexandratos, professor in chemistry from Hunter College. With us today in the studio, we have a group of honor students sitting in the green room, and they're now ready to post their questions. We have one of them with us in the studio. Chris is with us. Hello, Chris. Welcome.
How's it going?
Very good. Would you be kind enough to read a few of the questions?
Sure. First question is by Chris Fiore, and it is, after environmental remediation, how long does it typically take before a brownfield site can be redeveloped?
Good question. If the remediation is done well, and we know how to do remediation pretty well of brownfields, it's ready to go. It's not an issue then of allowing any natural recovery to occur. Usually that means removing the soil, taking the soil away, adding fresh soil, you're pretty much ready to grow. That's the story of Atlas Park in Queens. It was a brownfield, it's been remediated, it was ready to go for a mall as soon as it was done.
What is your opinion of the quality of the tap water in New York and neighboring states? Asks Matt.
Certainly in New York City, it's excellent. There's no question. We talked about that before, and so far as talking about it coming from the Catskill regions, it's as good as you're going to get, and I certainly recommend it much more than bottled water. So feel free to drink. And as for neighboring areas, it all depends where the water is from. If it's from wells, wells can be very good, but they're analyzed. I know parts of New Jersey, the water is analyzed. I get an analysis myself. I read it, and it's quite good. The metals content is indistinguishable. So it can be very good. Any concerns, ask for the local government to do an analysis, and it's not hard to do.
And another question by Damien. Is it common for people to be poisoned by eating fish that contain various contaminants in their flesh?
Not anymore. No, it used to be common. Used to be what raised the red flag environmentally was in the very early 1960s in Minamata Bay in Japan. People were getting a nervous disease, dying from it. Babies were being deformed. It was then realized that there was mercury in the bay thrown there by an industrial concern. The fish then were eaten by the people, and that's what caused the real problem. Here in New York, and I'd say in all major locales, the fish are monitored. The danger to humans is low, but you have to be aware. For example, in New York, we say there's a posting. You can only have 1 or 2 sea bass taken from New York Harbor a month. So it's an issue one has to be aware.
There's another fish question from Minaj. When buying fish, there's often a distinction made between farmed and wild-caught fish. Is there a difference in toxicity between the two, or is it generally considered safer to consume either?
I wouldn't say that it's safer to consider either. The problem, there may be a problem with the farm raised. They have to be given antibiotics because they're raised in such close quarters, and so they're given antibiotics to remain healthy and grow rapidly. But those things are analyzed for, so I wouldn't hesitate to eat farm raised. With that said, I'm assuming that there is some analysis done of the fish over time to ensure that there are no antibiotics in their system to a large enough extent to be harmful.
The next question is mine. Is there such a thing as a hazardous material that cannot be disposed of safely? What contaminants are particularly hard to clean up?
What particularly hard to clean out? Metals are very, very harmful, but they're not hard to get out. We understand what filters to use to get them out. PCBs are very, very harmful. We are not quite sure how to get them out, and that's why there is the dredging that's going on in the Hudson River to remove them. So we can get them out by a dredging operation, and then the soil that's dredged is then buried somewhere safe. So I wouldn't say that there's anything out there that once identified, we simply can't get out.
Next question is from Isabel. How polluted is New York City's groundwater? Would we be able to drink it?
Fortunately, we don't have to. So I don't know I have not seen an analysis of the groundwater. I do know that there are parts of Queens that are brownfields, and if there are aquifers below them, then that water would be completely unsafe to drink. But I don't know of any analysis that says, yes, stay away from it. But again, you won't have to make that decision. It's done for you. You've got good water coming down from Catskills.
Another question from Chris. Can you explain the process of hydrometallurgy and what safety precautions are taken?
Oh, what an interesting question. Hydrometallurgy, yes, I gave a lecture on that at the American Chemical Society meeting last year. Hydrometallurgy, so you mine the metal, you put the ore that has the metal in that you want, for example, copper ore, and you build a heap. You make a huge heap of this ore that's now finely ground, and then you pass an acid through it almost always sulfuric acid, which dissolves the metal, such as copper, into a solution, hence the word hydrometallurgy, water. It's all a water-based chemistry. And now you've got a water solution of the copper to which you contact another compound that is able to remove the copper, and then you can recover it, but usually by electrolysis, pass electricity through it, and now you have, in this case, the copper metal. So the biggest danger is in the leaching process. You have to have catch basins so that the sulfuric acid solution doesn't enter the environment, especially the groundwater beneath it. But that's pretty well understood. This is a very old process, and the safeguards are in place.
Next question from Tiffany. Who's responsible for taking samples of water, and how often is it done to ensure the water is consistently safe for drinking?
The Environmental Protection Agency at the federal level, at the state level, and at the local level, those are the ones that are responsible. Here in New York City, for example, we have a city Environmental Protection Agency. It has a special acronym to it. I don't recall it, but it has the word environmental. I don't recall it right now. It doesn't matter. It matters that the word environmental is in it. It's very good. It's a very good agency. It keeps tabs on everything very well. How often does it need to be done? I suspect, and I'm guessing here, but I would say every 6 months to do an analysis, and I suspect that they're pretty good at that.
And a question from Kari. What procedures must a new water source undergo to test its potability before it is used to supply homes?
To test a new water source, as for example, one were to dig a well, the two things that you would need to look for, and they're quite easy to analyze for, one is the metals that we've been talking about. For example, arsenic. Arsenic is a really big deal. You don't want to be drinking any arsenic, and there's an analysis that's done for arsenic, as there is for chromium and other metals, and this is part of the normal analysis that any local government would do. That's one thing, and the other thing is bacteria. We look for fecal bacteria. For example, the groundwater can get contaminated from wastewater, so bacteria is looked for, and the last thing, organic molecules such as steroids and antibiotics are examined. Again, this is well known. All those methods of analysis, to use the technical term, atomic absorption spectroscopy and gas chromatography, liquid chromatography will tell you all you need to know.
I would like to thank Chris very much for posting all of these questions from the honor students. I have one last question before the program closes. I know, Professor Alexandratos, that besides your concentration in chemistry, you will be teaching another course that overlaps perhaps with some additional sciences or disciplines, and it involves philosophy to a certain extent. I think somewhere in the title there's the word epistemology. I'm not sure. Would you share with us something about this course?
Yes, I'll be glad to. Just be sure you're ready to cut me off at a moment, because I can keep talking for the rest of the hour on just this topic. It's called The Search for Knowledge and the Problem of Certainty. Very interested to understand, first of all, what is knowledge? What does it mean when you know something? And then, as we look to understand everything that surrounds us, how do we search for knowledge of what surrounds us, of nature, of reality? And then we ask the question, but are you sure? Of everything you figured out, are you certain? So we ask, what is knowledge? And we begin at the beginning. Plato, in the dialogue with Theaetetus, asked just that question. And since we don't have all this time for me to develop it, I can tell you the final answer that Plato kind of gives is that knowledge is a justified true belief. You have to believe something, it has to be true, that is to say, it has to correspond with reality, and you have to be able to justify it. That is to say, give an account as to why you think this is true. That becomes knowledge. Long story short, to understand what it is all around us, it evolves naturally into substances. Substances is the domain of chemistry. Chemistry allows you to understand things. In the 1800s, people imagined these molecules, and they didn't know if this was true. Up until 1960, 1970, we had no earthly idea whether we were sure, and now we have pictures, and now we're sure. And it's a beautiful, beautiful story.
This has been the program Innovation Unedited. I'm your host, Angelo Lampousis from City College of New York. In the sound was Aaron Sloduvnik, and who has been also making these amazing musical selections. The honor student today was Chris with us, and we want to thank very much Professor Spiro Alexandratos, professor in chemistry from Hunter College, who gave us this opportunity and educated all of us, general audience students, and myself as an educator. I don't miss an opportunity to learn from the more experienced professors. Thank you so much for being with us.
A pleasure, absolute pleasure to be here. Thank you.